Hello, this is Mr. Norris. The purpose of this video is to be able to talk about different kinds of transformations and to introduce the idea of transformations. In my window on the left, I'm going to go ahead and draw in a triangle. We're going to work with this triangle and perform some different kinds of transformations on that. What do I mean by transformations? Let's think about that. So first of all, it just really depends upon the kind of transformation that you're talking about, and we're talking about several. We can talk about many different kinds of what I want to think about transformations about is motions. So what kind of motions could we perform on this triangle? Well, we could stretch it, we could shrink it, we could shift it, as in we could move it up and down or left and right. We could reflect it across some axis, like if you imagine this entire coordinate plane on a piece of paper, we could fold it along this axis if we wanted to. So we could say that we could reflect it. I think I'm just going to say flip instead of reflect right now. And we could also think about turning this thing. I mean, we could take this entire triangle and we could turn it in this direction, or we could turn it in that direction. So we could also think about some kind of turn. The first thing that I want to talk about is a flip. So let's look at this for a second, this triangle. Let's suppose for a second that I want to flip it across some kind of axis. So I'm going to tell my computer that I want to think about this triangle, and I'm going to tell it I want to reflect it somehow. Maybe I want to reflect it across the y-axis. And if I do that, we see what happens. We imagine that we take this entire triangle and we just flip it right across that axis. So I'm going to identify our first kind of transformation that we're going to be studying in this unit, and that's a reflection. Let's take a second and try and zoom in on this reflection. I don't know if it's going to let me do it. Yep, here we go. So I'm going to zoom in on this for a second. Notice that when I flipped across this axis in the center, and forgive the drawing at the moment, that from here to here we're talking b going about 3 units from the y-axis. And from here to here we're talking about b also going 3 units from the y-axis. So it started here at this point, and it was a distance of 3 from the y. But when you reflect it, the new image is still a distance from 3 a distance of 3 from the y-axis, except it's 3 units to the left of the y-axis on this side, whereas earlier in our original image we were talking about 3 units from to the right of the y-axis. Similar idea here. Imagine the distance that we are from the y-axis to c. So we're talking about 1, 2, 3, 4, 5, 6, 7. So a distance of about 7 from c to the y-axis. Well, that's 7 units to the right of the y-axis. Same principle with this c on the left-hand side of the y-axis. Still a distance of 7 from the y-axis, only now it's 7 units left of the y-axis, whereas over here it's 7 units to the right of the y-axis. So I just wanted to talk a second about that general pattern that we see in a triangle, and in this case in the reflection of a triangle across the y-axis. So let's write out what we need to think about when we're talking about reflections. Well, on the one hand, we need to consider the axis of symmetry. In this case, the axis of symmetry that we were talking about was the y-axis. We also need to consider that the axis of symmetry does not have to be the y-axis. We could have chose to rotate across, to reflect across the x-axis. We could have chosen some line, like reflect across the line y equals x. So we have any option for an axis of symmetry. Just something that we want to consider. In fact, let's try and imagine this original triangle that we were talking about flipping across the x-axis. Can you think about what the new image would look like to flip that across the x-axis? Well, let's see. I'm going to tell my computer to send that across this x-axis, and bang, there it goes. So you can see the main idea of reflecting, and you can see that it depends upon the axis that you're talking about. Now let's move on from reflection to talk about a new kind of transformation. So I've gotten rid of my triangle, and now I'm going to look at this sort of odd quadrilateral that we've got here, this sort of odd looking polygon. And we're going to talk about a new kind of motion with this, specifically a translation. A translation we sometimes refer to as a shift. meaning that we can shift it upward, we can shift it downward, we can shift it left, or we can shift it right. Before I move on, I want to talk about one main idea that's going to recur throughout the different kind of motions that we discuss, and that's the notion of a pre-image and an image. What we're looking at now is our pre-image. It's our original polygon, line, or figure, meaning that we haven't formed any kind of motion on it yet. Say I wanted to flip this thing. The image that I got, that new picture, would be called my image. It is the polygon, the line, or the figure after we've performed some kind of a transformation on it. So I'm going to tell my computer to consider this polygon that we're talking about. So I want it to think about this entire polygon, and I want to translate it. Let's see if it'll let us do that. So I'm going to go up to translate by, and I'm going to tell it that I want to go 3 units down and maybe 3 units to the left, and then maybe 6 units up. So let's see if it'll let us do that. So each point, and let's see if it'll let me zoom in on this a bit more. Each point, this A, went up 6 units. So that's a distance of about 6. And then it went left, looks about 3 units. And that's true for any point. A goes to A prime, up 6 over 3. D goes to D prime by going up 6 and over 3. So that's the general idea that we're talking about. All that we're worried about with any kind of a translation is just some kind of a shift. So we can talk about going up, down, or left and right. One clear characteristic that you want to notice in a translation is that these polygons haven't been turned at all. It looks like they're at the same orientation, they're at the same space. Even though they've been shifted a bit around the coordinate plane, they haven't been turned at all. Whereas if you think about taking this image and, let's say, maybe reflecting it across the y-axis, you've definitely turned that polygon. You've definitely made it flip from one side to the other side. So it's pretty clear if you're looking at this that there's a big difference between reflecting something versus translating it. So this is all we're concerned about with translations and reflections. Now we're going to move on to another type of motion called a rotation, and I think I'm going to get a new polygon for that. Now I've decided to use this sort of oddly shaped pentagon for our demonstration of a rotation. In a rotation, you have to consider several things. In the past, with the translation, we only had to consider up, down, left, and right. With the reflection, we only had to consider the axis of symmetry that we were talking about. With a rotation, you have to think about the fact, are you turning clockwise or are you turning counterclockwise? So this is definitely something to consider. You also have to think about your center of rotation. Let's look over here on our screen at what that might look like. So I'm going to tell the computer that I'm concerned about this particular polygon, and I'm going to tell it that I want to rotate it about a center that's going to be here at 0, 0. So I'm going to click 0, 0, and now it's going to let me rotate that polygon. So we can think about rotating this image any number of degrees that we want to. So here I have a 90-degree rotation. Maybe I'm going to take it all the way out to 180. Maybe I'm going to take it around to 270, all the way to where it's 360 degrees and right back where we started. So we can determine also the number of degrees that we want to go. As you can see down here, I'm going to zoom in for a second. My center is right here at 0, 0, and that's where I was that's what I was rotating my polygon around. Okay, and so I'm going to write in our notes that in addition to center and going clockwise or counterclockwise, we're also concerned about the degrees of rotation, how many degrees that we're rotating it. Now I picked 0, 0 as my center, but note I can choose my center to be anywhere in the coordinate plane. And it's going to make the image be a lot different if I do that. So if I decide to move my center of rotation up here, it definitely looks a lot different than if it were at 0, 0, than if it were down here, if it were up there. The center definitely matters. So in this part, we've talked about reflections, we've talked about, we've talked about translations, and we've talked about